So our next presenter joining us from Sydney will be Hannah Lazenby. Hannah's a structural engineer trained in civil engineering from the University of New South Wales. Her adaptable workflow for the adaptive reuse of the Ken Rosewall Arena in Sydney, a project she's going to talk to us about today, was really critical in Arup's ability to respond to client and architect requirements in an incredibly tight time frame. It's a great story about how new approaches can help us not only extend life cycles of assets, but also expand to new uses. So I'm delighted that Hannah will be sharing it with us. Hannah, please go ahead.
Thanks, Bree. Today I'm going to be talking about how we were able to extend and enhance the life of an existing underutilized asset, the Ken Rosewall Arena. By approaching this project with a digital mindset and adopting a non-traditional approach to delivery, we were able to design and construct a World Cup stadium within a super tight timeframe. Ken Rosewall Arena was constructed for the 2000 Sydney Olympic Games, and it was actually originally designed by Tristram during his time in the Sydney office. We enclosed this originally open-air stadium with a 100-metre spanning cable net roof in order to prepare the venue for the World Cup tennis event. Here are some images of the original building. You can see that the bowl was made from precast concrete, and there was a small canopy roof, which provided some shade to the upper tier. However, it left the lower tier and the court exposed to rain and the harsh Australian sun. Of all the Olympic facilities, the Ken Rosewall Arena had special recognition by being awarded the Sir John Salmon Award for Excellence in Public Buildings. Our client wanted to bring a new life to this award-winning stadium by transforming it into an all-weather, dual-purpose venue for both netball and tennis. Our brief was to design and construct a cost-effective roof that enclosed the stadium within 12 months. Our key collaborators were Cox Architecture, Fabrication as lead contractor for the roof, and AW Edwards as the managing contractor. Let's take a quick look at the structural solution. We utilized the circular form of the original building and designed a self-resolving tensile cable net roof to replace the existing canopy roof. The extremely lightweight structure minimized strengthening of the bowl and omitted the need for any foundation strengthening. The program was extremely tight. We had 12 months from project commencement to the completion and the opening event. It would not have been possible to meet this tight deadline without adopting a digital solution. It's not uncommon for Arup to develop some form of digital workflow, so I won't spend too much time on this, but in short, we used 3 key tools to automate our design. We used Rhino, Grasshopper, and GSA. For the duration of the project, the design was kept solely in a 3D environment. This made it extremely fast to reanalyze varying geometries. Our automated analysis was used as the basis for our member design and also for the connection design. It was also used as the basis for the architectural setup and for the Tekla fabrication model and the preset cable geometry. The digital collaboration with designers, architects, and contractors ensured the delivery of a high-quality design. We made 3D models of all of our connections. These 3D models were used to create finite element analysis models to design all of the critical connections. The 3D modeling of the connections enabled us to deliver the design in a non-traditional way. From the beginning of the project, we had agreed with the client that no traditional drawings would be issued. Our 3D models, along with sketch packs, just like the ones that you can see here, were sent to the fabricators. The shop detailer sat in the Arup office for the duration of the project, which allowed us to collaborate with them and to take advantage of their experience and their expertise, further streamlining the time from design to fabrication. The digital delivery and the 3D modeling of connections made the design process much faster, and it meant that the quality of the design was not compromised for time. It also dramatically reduced the number of RFIs. From memory, we only had about 2 RFIs for all of the steel details. All of the fabrication was undertaken in China, and my colleague was able to visit the workshop, which was just outside of Hong Kong. 3D surveying was undertaken to accurately model the interface between the new and the existing elements. All of the new steel was painted in white to pay respect to the original construction, whilst also highlighting the new life given to the structure. The digital tools utilised for the design and the fabrication of this structure ensured a seamless interaction between the existing bowl and the new roof. By avoiding demolition and reconstruction, we were able to extend and enhance the life of an underutilised Olympic stadium. We designed a highly efficient, lightweight structure that was optimised to meet the client's requirements. These key design features allowed us to deliver a low-carbon solution. We've used Arup's embodied carbon calculator tool to get a rough idea of the saving in embodied carbon that we achieved by regenerating the existing building and adopting a lightweight solution. You can see here that the combined bowl and roof has an embodied carbon of 2.9 million kilograms of CO2, compared with only 1.2 million for the roof alone. There was a significant saving in retaining the existing bowl and optimising the design. As you can see in this photo from the ATP Cup semi-finals, we have given this stadium a new life, and it was the digital processes and the delivery which allowed us to achieve a high-quality design within the 12-month timeframe. Ken Rosewall Arena is a great example as to how we can help to shape our cities by bringing new life to existing assets and contributing to a more sustainable future. Thank you for listening. I look forward to answering any questions shortly.
Thank you, Hannah. That was an extraordinary project, cost, time, and a greener way.